What is the largest black hole known to man? There are many huge planets and extremely massive stars in the universe. While these lovely heavenly bodies are stunning to view, there are other things that cause existential dread as well. Black holes are at the top of that list. Some of the oddest and most interesting objects in space are black holes. Because of their enormous density and powerful gravitational pull, not even light can elude them. These sticky beans devour everything in their path. And Sagittarius A star, a supermassive black hole, is at the center of the Milky Way. The enormous object is located 26,000 light-years from Earth and has a mass that is around 4 million times that of the Sun. However, there is a black hole that is so large that we can extract millions of Sagittarius A star black holes from it. How big is this black hole, and why should we be wary of it? We must first understand what a black hole is before we can examine the biggest black hole ever discovered in the known cosmos. We turn to NASA's subject matter specialists for the solution, who state that black holes are areas of space with gravitational fields so powerful that nothing, not even light, can escape. Massive amounts of a substance are crammed into minuscule spaces to form black holes. According to NASA, it's comparable to cramming a star 10 times bigger than the Sun into a space no bigger than New York City. Since nothing can escape a black hole, they are invisible to our current instruments for detecting light or radiation. Instead, scientists can only detect black holes by observing their local effects on gravity and light. We can observe the effects that a black hole has on a star, for instance. If the star passes by one, a star that approached the black hole too closely had a tidal disruption event, a TDE, which was caused by a recent phenomenon known as ASA SSN 19BT. In essence, the star was destroyed by the black hole's enormous gravity, which also caused stellar material to be ejected into relativistic jets or form an accretion disk around the black hole. At the moment, it is thought that every galaxy has a supermassive black hole. Black holes come in at least 3 different varieties, each of which forms differently, despite popular belief. First, primordial black holes can be as small as a single atom, but they have a lot of mass. They most likely formed right after the Big Bang. The second is small yet dangerous, stellar black holes. A star may collapse or fall into itself when it has used up all of its fuel. The new core of smaller stars, those with masses up to around 3 times that of the Sun, will eventually transform into a neutron star or white dwarf. But as a bigger star disintegrates, it keeps getting smaller and smaller until it forms a stellar black hole. Black holes created when individual stars collide are comparatively small but immensely dense. One of these objects has a diameter of a city and more than 3 times the mass of the Sun. As a result, the gravitational attraction on objects nearby is extremely strong. The gas and dust from surrounding galaxies are then ingested by stellar black holes, which keeps them from contracting in size. The third one, supermassive black holes, are still somewhat mysterious. Although many little black holes exist in the cosmos, supermassive black holes predominate. Although they are millions or even billions of times more massive than the Sun, the diameter of these giant black holes is around the same. It is hypothesized that such black holes are at the heart of almost every galaxy, including the Milky Way. The origin of such massive black holes remains a mystery to scientists. Once these giants have formed, they continue to increase in size by absorbing mass from the gas and dust that surrounds them, which is abundant in the center of galaxies. It's possible that hundreds or thousands of microscopic black holes will merge to form supermassive black holes. Large gas clouds that collide and quickly accrete mass could possibly be to blame. Another possibility is a stellar cluster collapsing or a collection of stars collapsing at once. Also, big, dark matter clusters may give rise to supermassive black holes. We are unable to directly detect this substance through its gravitational pull on other things, but we are unable to directly observe dark matter. Thus, we do not know what it is made of. High-energy collisions are one of the other hypotheses regarding the formation of black holes. These, however, have not been found to be present. During the Higgs boson quest, this notion briefly alarmed people. People believed that the technique which made use of the CERN Large Hadron Collider may produce an event that would destroy the planet. Knowing how these celestial regions form is one thing, but there is one unanswered question. What takes place within a black hole? The reality is that we can only speculate as to what exactly takes place within a black hole. However, according to one hypothesis, anything that enters a black hole's singularity gets compressed into an incredibly small point. Any material that crosses the black hole's event horizon is disintegrated into subatomic particles before entering the singularity. The event horizon separates anything that enters from the rest of space-time. At least, that's what we believe is happening at the moment. In 1916, Albert Einstein's general theory of relativity made the first prediction about the existence of black holes. Many years later, in 1967, American astronomer John Wheeler first used the term black hole. Until recently, black holes were solely understood as hypothetical entities. Cygnus X1 in the Milky Way's constellation of Cygnus, the Swan, was the first black hole ever found. According to NASA, the first indications of the black hole were discovered in 1964 when a sounding rocket discovered astronomical X-ray sources. Astronomers discovered in 1971 that the source of the X-rays was a bright blue star orbiting a mysterious dark object. It was hypothesized that the discovered X-rays were caused by stellar material being gobbled up by the dark object, an all-consuming black hole, after being peeled away from the blazing star. The unicorn black hole, which is 1,500 light-years from Earth, is the nearest to our planet. The moniker has two distinct meanings. The black hole candidate is almost unique due to its extremely low mass, which is roughly 3 times that of the Sun, as well as the fact that it is located in the constellation Monoceros, the unicorn. The Event Horizon Telescope (EHT) team published the first black hole image ever taken in 2019. While the telescope was studying the event horizon, or the region past which nothing could escape from a black hole, the EHT discovered the black hole at the heart of the galaxy M87. The abrupt loss of photons is depicted in the image. Additionally, since the astronomers are aware of what a black hole looks like, it opens up an entirely new field of study for them. A fresh image of the massive structure at the center of M87, as seen in polarized light, was released by scientists in 2021. The new image reveals significantly more information about the black hole because polarized light waves differ in orientation and brightness from unpolarized light waves. The image makes it obvious that the ring of the black hole is magnetized, since polarization is a sign of magnetic fields. What then is the largest black hole ever discovered in the universe? Ton 618 contains the biggest black hole ever discovered in the known cosmos. This is a hyperluminous Lyman alpha blob with a 6x6 by 1010 solar mass black hole. Its mass is almost 66 billion times greater than that of the Sun. The distance between Earth and this supermassive black hole is 18.2 billion light-years, and it can be found between Canes Venatici and Coma Berenices. One of the brightest objects in the cosmos is Ton 618, which is assumed to be a galaxy's core. There is still a lot we don't know about this cosmic body, but for now all we know is that it most likely contains the largest black hole ever discovered. Of course, if we put more of a focus on astronomical exploration, we might find bigger ones. The universe is, after all, a vast place. Supermassive black holes are thought to be present near the galactic center, as we've already mentioned. Sagittarius A star is the name of the object in the center of our galaxy. This black hole has a mass of about 4.154 by 106 solar masses and is also 4 million times the mass of the Sun. It's far smaller than the largest black hole ever found in the known universe. Its magnitude may not be the most intriguing aspect of this black hole. It has to do with the fact that we can see this black hole. The accretion disk surrounding Sagittarius A star's event horizon was visible in a photograph taken by the Event Horizon Telescope and released by astronomers in May 2022. Although it's not exactly a photo of a black hole, it does show the evidence that one exists there. The event horizon of a black hole, which is the region outside of which nothing can escape, determines how big it is. Sagittarius A star's diameter was previously estimated by scientists to be 16 million miles, that's 26 million kilometers. When compared to the black holes created when large stars die, the Milky Way's black hole is enormous. But according to astronomers, almost every galaxy contains a supermassive black hole. Sagittarius A star pales in comparison to the majority of these and is uninteresting. Measurement of supermassive black holes is quite challenging. They are hidden by the gas and dust that fills galaxy centers and are far away. In comparison to the expanse of space, they are likewise comparatively little. Only 1 in 10 billion photons of visible light can reach Earth from Sagittarius A star, which is located 26,000 light-years away in the Milky Way center, as the majority is absorbed by gas in the path. Astronomers measured the radio emissions from the gas surrounding the black hole because radio waves can travel through gas much more easily than visible light. The Milky Way is thought to contain between 10 million and 1 billion stellar black holes, each with a mass roughly equivalent to 3 suns. We now think that Ton 618 is the biggest black hole yet discovered. Even bigger ones might be out there that we haven't yet discovered. On the other hand, a group of scientists from around the world thinks they have found the black hole that has grown the quickest in the last 9 billion years. They calculate that the supermassive black hole has a mass of 3 billion suns and consumes the equivalent of 1 Earth every second. The team was searching for pairs of binary stars inside the Milky Way galaxy, not for a distant supermassive black hole. The crew found a weird object among the binary stars, which they later identified as the quasar. The bright constellation of Centaurus, which is a vast celestial sphere more than 500 times bigger than the supermassive black hole at the center of the Milky Way galaxy, is where it has been found. The quasar, also known as J114477-430859.3 or J1144, is 7,000 times brighter than the entire Milky Way. The supermassive black hole was more or less halfway across the cosmos, according to the principal researcher, Dr. Christopher Onken of the Australian National University. The light that we're seeing from this growing black hole has been traveling to us for about 7 billion years, he says. The researchers discovered that J1144 was the brightest quasar in the last 9 billion years of cosmic history. There are other black holes of comparable size, but they often date from a far earlier period in the universe's history, when galaxy mergers were considerably more frequent. That saw the objects containing bright lines, which indicates that gas was flowing quickly and proves that a supermassive black hole is what's driving it. Supermassive black holes power quasars, which resemble stars but actually emit light from the accretion disk, the ring of gas, dust and stars that surrounds the black hole. This material becomes extremely heated and produces dazzling light as it's drawn towards the gaping mouth of the black hole by its powerful gravitational pull. The fact that there is so much extraterrestrial matter circling the black hole makes it possible for scientists to calculate its mass. There have been quasars found that are brighter, but J1144 stands out because it is both far farther away and brighter than other objects of a similar age. The researchers were able to review earlier data, and they discovered that the massive quasar's brightness has remained constant throughout time, indicating that it's a black hole and is continuously gobbling up gas and anything else that happens to be in its path. Binary black holes. Double trouble. Astronomers discovered gravitational waves from merging star black holes in 2015 using the Laser Interferometer Gravitational Wave Observatory, LIGO. It was discovered that two black holes could spin in the same direction or the opposite direction as they spiral around one another. Two ideas exist about the formation of binary black holes. According to the first theory, two stars that were born together and died violently at roughly the same time gave rise to two black holes that formed in a binary at or near that same moment. The two black holes that were left behind would have shared the same spin orientation as the companion stars. According to the second hypothesis, two black holes in a star cluster merge at the cluster's center. According to the LIGO scientific collaboration, these companions would have unpredictable spin orientations when compared to one another. The creation scenario is supported by LIGO's discoveries of companion black holes with various spin orientations. What will happen if you fall into a black hole? Any chance of survival? Theoretically, if you fell into a black hole, you would be stretched out like spaghetti by gravity, but you would have actually died before you reached the singularity. According to a 2012 study in the journal Nature, the event horizon would behave like a wall of fire that would instantly kill you due to quantum phenomena. Black holes don't suck, contrary to popular belief. The big black hole is most clearly not a vacuum that causes suction. Instead, like with everything that has gravity acting on it, like the Earth, items fall into them. Black holes are still a great subject for science fiction books and movies. They are also quite the enigma. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.